Hello everyone, and I'm continuing tuning this nice Akai GX-99 R99, so it's a reversible deck. And if you remember, in my previous video I completed tuning Playback, and Playback was tuned to the standard, and it was interesting to watch video from another restoration channel when there was no details, but when it was discussing how the restoration went through, the serviceman told that he observed the same -4 decibel difference on the high frequencies in the playback mode comparing to the standard. But when he tried to tune up the deck, and he was not able to tune calibration unit to perform as needed. So far, my results are positive. I was able to tune it up. This deck has a significant disbalance between left-right channel on the bias. One channel was fine, but other was fully off. I'm adjusted this. Now it's fine. All right, now let's see calibration process. I'm starting with setting 2 volts. All right, 400 Hz, and I click in calp. So it will calibrate tape, then it will measure level. You see, it measures, it reduces level, and then it's turn on the signal when measurement is complete. All right, you see both channels appear, measurement complete, everything is tuned. And I have 2 modes, normal mode, view, and peak level. When it shows more detailed view, right, of the pike levels. And as you see, it tuned it to Dolby level. All right, so maximum at Dolby. And now, if I start recording, so let me show source, tape. There is 1 decibel difference, and I can observe this 1 decibel here on the display. So source, tape, all right? I will continue tuning. I'm not sure yet that I'm done with it. The process is lengthy and requires lots of efforts. Now, let's switch to -20 decibel by adjusting from 2 volts to 200 millivolts. And let's see frequency response for this deck. I will increase amplitude here, so you would be able to see. Here's the levels, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, about 1 decibel, but no significant changes. 11.4, 12, 13, 14, 15, 16, 17. And that starts interesting. You see how jumping right is. And no one would like this picture, right? And I found an article, it's a very old article, when the deck was just released from 1985 or 1996, when they observed exactly the same behavior, right? Now, see, I will reset counter to 0. Let's record about 20 seconds, and I will show you how it will play back that signal. An interesting observation that it's not the recording, it's modulation from record head to the playback head, which causes it. Okay, 28 seconds. Let's rewind back. 7 seconds. And that's how even it is. There is fluctuation, but 1-2 decibel. No, not that bad as it was before, right? And it's normal tape. That's exactly is described in the article. All right. I will probably later show you, but you may download this article. It's available on Hi-Fi Engine. So the deck records and plays really nice. All right, now let's try calibrate the different kind of tape. Let me put in chrome tape. I will close it. I will run calibration process. Oh, I need to adjust amplitude. All right, it's measuring. All right, so for some reason it measured differently. Let's do one more time, because I turned its on levels significantly later. All right, now it's measure levels. And you see mole level is right here, +4. Sometimes you see left-right channels are uneven. I didn't figure it out yet why. But after a few attempts, sometimes it works pretty fine. Again, I believe something wrong between levels. But let's try records. Let me change amplitude. That was a frequency. It was too high for CPU to measure. Let's try again. Let's do amplitude 2 volts, 400 Hz. Yeah, that's why. It's tried to measure high frequencies. No. Yeah, you see at 400 Hz it measured properly. All right, recording. Let's see. So left channel about 2 decibel lower than the right channel. Now let's see frequencies. Like 1, 2, 3, 4, 5, 6, 7, 9, 10. It keeps the same level as it was. 11, 12, 13, 14, 15, 16, 17 starts as bumpy right. 18, 19, 20. It's even higher now. At 20, 21, 22, 23. At 23, it's in phase. Really. Yeah, you see, below, so like 15 kilohertz is in phase, but going lower phase is like full wave off. I didn't understand yet, because someone was touching the whole head setup here. You see, the paint is not original, it's covered with different. Alright, I tried to tune up Azimuth a little bit, but everything else they pass. Like, I probably would need to spend more time with this deck than I thought. Now, let's try metal tape. Again, let's do 400 Hz, 2 volts, and let's calibrate for this tape. and measurement complete. All right, so this time, how much? Oh, it records not bad. Let me switch mode. So -20, like a little bit disbalanced between left to right. Let's see frequencies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Keeps 11, 12, 13, 14, 15. Right channel, bumpy right. 16, 17, 18, 19, 20. Keeps 21, 22, 23. All right. Let's see how it records. 23.4. All right. Let's reset counter. Oh, definitely, it cannot. All right, so this probably was intermodulation. Let's see how it will record 18.4. All right. Oops. Sorry. Let's change it levels. Let's try again. You see, mall level, and like another one point is a mid-range level. So it shows small. It doesn't show sol here. Initially I saw like two dots, like one mall, one sol. No, small and mid-range vocals. Okay. Now, ready to record. Let's see frequency. Come on, we don't record it yet. 50, 50, you see different levels, left, right. For some reason it's calibrated left, right differently on the levels. Maybe aging, maybe parts. Let's try again. Let's do, yeah, but without calp. No, still left, right is different. Switch manual. Why the balance is so different? Now they're even. All right, now I have to adjust level a little bit. Like that. All right, 18.4. Recording. Counter reset. It shows full mass. Not in a commit, yeah? And that's recorded. So it's technically it's records. It's out of phase. I need to see if I can do it better. But it records up to 20 kilohertz as was designed. All right, let me work more on it. Like, I don't like the difference between left-right channel on the levels. There are so many pots, and this deck shows a bias. These two and these two. Like, this is like type 1 chrome metal. There is in the holes is the levels for the indicator. It's validated. These two I don't remember. And there is a bunch more. 2 for DAC and ADC. Like 4 and 2. Alright, so probably something is off. because here one pot was really screwed into a different direction. Let's see. Let me work more on it, see you soon. And here guys, I'm continuing my investigation of what I found, that if I adjust bias so it would be uneven, right, then I get recording phase pretty nice. So see, 5, 8, 10 kilohertz in phase, 15 in phase. So probably that was the reason someone tried to screw up the bias, but bias is, I guess, 5 and more decibel out of control. Okay, the higher the frequency, the bigger the difference. How many? 6 decibel. Okay, 7 decibel difference at 14 kilohertz. I'm just looking if there is any way to cancel the after tuning. I don't see any. Two memories. All right. That's not simple task. And what I mentioned, that screen is getting dimmer again. Like it's not so bright, I believe, or maybe just like my eyes use it too. I was looking into computer, reading a lot. Maybe just like I need some time. All right, that's how interesting things are, really, with this automatic calibration. Adjusted AD converter. It was off, like it was like 4.3 volts reference voltage versus 5 volts. Then I adjusted verified levels as in service manual. That's a procedure. Okay, let me see. But it's definitely something with the head, because as you may see, like as soon as we get bias, we get the record azimuth, but bias is too low, so I need to understand what is affecting it. Maybe tilt, maybe something else. I have no idea. I have read lots about this deck, and like these materials here I use it is pretty hardcore. It's magnesium, zinc, and beryllium alloy to make it really hard, and like there's micron gap around it, so they made it so it was reverse and maintain azimuth. Even these screws here made with very firm material, so over time they would not degrade, and so many good ideas, right? All right, let me see. So far playing, trying to make it perfect. See you. Okay guys, while I'm continuing working on the deck, I decided to measure wow and flutter. Wow and flutter is very stable. You see above 0.04%. Speed is stable, 3000 Hz. Like that number only after point is changing. So pretty good results. I had to clean up capstan shafts pretty well to get to these values, and additionally use it isopropyl to clean up the surface on capstans where the belt is rolling. Before it was 0.2. I was scared what happened. All right, because I don't hear it on the songs, and here like boom, big numbers. Good. So continue tuning. Like I went through procedure for this DAC, which is levels for the record level, automatic calp levels. It's these 4 ports. This port is for DAC here, like now I'm checking generator levels. And the original procedure is like required to remove this board, unsolder wires from the board below. They're like in the middle and here on the corner, and then like put this board back and start tuning. It's oh my, I just don't have words how they designed it. And also, like I removed 100 picofarad I installed before. I'm not sure if I told you already, because sound was so bright that I would not listen to it. It's just too bright, right? And now I'm trying like to tune everything back to the proper values and see how it will work. And I'm currently, I believe, in ref mode. So like just the same, like hold the Chrome switch and power on, and you get into the ref mode. And as a result, when you start recording, see, no automation like will work. So we need to tune all levels first. These 2 ports are responsible for level, recording level. These 2 for normal tape bias. Now I'm checking the metal bias. And like then we'll check Chrome bias, adjust, and then after that I will switch automatic calibration, and we'll check the charts and how everything works. See you soon. All right. So let's see. Automatic calibration. Recording. Normal tape. Almost like 19 kilohertz, almost 20. Pretty good. A little bit disbalanced at left-right channel, but it is what it is. Okay, let's see what it can do, like -10. And 0. So left channel is not the same. All right. Not sure. I have to check bias one more time after I'm adjusted for chrome and metal season. Okay, recording in the ref mode without calibration. That's how well I was able to straighten up. Pretty good, right? Type 1 tape. Now. Normal mode. As soon as we click record, it will calibrate. Why it's decided that it's tuned? Recording. Pretty close, really. Not bad results. So now let's see how it will calibrate chrome tape. That's the chrome tape. No, it's probably tape. It's not that good. It's maybe disbalanced between 2 channels. All right, and let's see metal tape. And here is the metal tape. I I'm not sure what with the metal bias here. It's pretty weird looking. Guys, old decks, even new decks don't guarantee perfect results. And that's the source mode. So from time to time it does it with the right channel. So probably we need to try again. Like, not sure why it's happening. Even in the source mode. You see? And I tried manual adjustment. Doesn't help. I'm not sure why. Sometimes it does. It's like probably source tape mode. No, nothing changes. I'm not sure why. Let me power off. And it happens like one time out of, maybe 2 times out of 10. When like during recording, it's changes the source level, like balance between them, like. It remembers that it was tuned. No, nothing changed. Let's try other tape. No, now it decided that so in source mode channels will be different on the high frequencies. You see, it's up to 6 kilohertz, pretty close. And after 6 kilohertz, there are some issues. So maybe some capacitor is fading. But to find it in this deck, have you seen the number of pairs? We have 2 of these birds. All right, let me see if I can do it. Probably it will be another day, then another day, then another day. We'll see. Hey guys, so technically I did nothing. I just waited a little bit. And here is the source, type 1 tape, and that is the tape. You see, like there is some like 1-2 decibel gap between 2 and 8 kilohertz, maybe 2 and 5. No. Okay, let's do the charts. Let's do frequency sweep. And I meet you in a moment. All right, that's the source frequency response. So you may see in more details. Goes up to 20 kilohertz, then filter it. All right. Now switching to the tape. This may take some time. But it will show exact response. Yeah, that's all, like about 1 decibel lower. And like in the vocals, 1 decibel higher. That's weird, probably tape issue, I'm not sure why it's not linear, but you see this gap on 16 and a half, like 17 kilohertz, a little bit. Probably let me run one more time, like I would not hold you, I show you results. Well, it reproduced exactly, so that was the bumpy ride I showed you earlier in the video, when like record head affects the playback head during recording. Now I'm just in the pure play mode, and play and recording just to make sure that we would see the real results. And technically don't record above 17 kilohertz on the type 1 tape. But at least to 17 kilohertz is pretty good. So let's extend range at 16 kilohertz. Interesting. This older decks, like it's 1985 when this deck has been released. So I'm not sure when this was like manufactured, exactly this one, but I believe they were like not long, like 2-3 years on the manufacturing line. All right. Okay, continue working on. I hope I will dig it out. My understanding is this imbalance between two channels. It's capacitors around like these microchips, which switch source and tape mode. And probably those capacitors are drying out and needs replacement already. I will discuss with owner what to do, because like it just was sitting, and after that, as you may see, white noise. Yeah, it's pretty good. No problem between left and right. And it was just sitting longer. I did nothing. I didn't tune anything. And even didn't power off. I was digging through schematic. I was trying to understand where is this signals, and that's the microchip. This one, 51133. You see one channel goes from line in, goes through this capacitor chip, another capacitor, it goes to line out right away. Okay, so it switches source and tape. So source goes directly, I believe, and tape, or maybe it's just amplifier, so I didn't get it, because I didn't find yet where is the MPX filter implemented. That's everything is so like cumbersome on these boards. We'll see. See you soon. Hey guys, and I'm continuing working on this deck and currently tuning the generators, right, for 8 kilohertz and 400 gigahertz. And here is 8 kilohertz when this was pins like 5 and 6 checkpoints disconnected from the ground. We are in the test mode, which turns on when we like turn off the deck, then keep the switch for chrome tape and turn on deck and keep it for 5 seconds. It will get into the test mode when calibrator would not work. And I had to disconnect the wires as been like instructed right here. To have this possibility to tune, we need to disconnect this middle wire, which is like test tone off, right? And they recommend to disconnect this too, but I didn't because it's too hard to get there, right? And now I was able like to set the levels properly, and ports are not at the same position as was before. So 400 gigahertz was off. 8 kilohertz is technically almost there, right? Complex procedure for tuning, but if you follow it precisely, I believe it will good results. Also, I was playing with frequency response for playback. I set up 2 capacitors for 100 picofarads, as you seen in my previous video. Then I removed them. Then I listened more for the tapes with Dolby and decided no, like we need to have a precise output. So I set up and tuned everything to match the proper curve. I tuned the bias and levels, recording levels in the test mode. Now I'm tuning generators. I tuned the ducts as instruction. And now I will solder the wire back and would be able to finalize testing and see how everything performs. So, but it's exactly is in the article from 1985 when the deck was tested by the professional. He tested and posted it in the magazine. So you may find it on Hi-Fi Engine. Pretty interesting. Like I'm getting the same results. So like heads affects each other. As soon as we go like above 15 kilohertz on type 1 tape, I see bumpy right. But when I record and then play, so high frequencies are all there. So like this intermodulation between two heads happens. All right. So it records like up to specs. So I check it like they head spec like plus minus 3 decibel. Like it's pretty wide range, and it falls there. All right. So let me solder wire back and let's continue testing. See you. All right. I used calp tuning and now I'm recording, and that's how sweep look like. You see a little bit rise above 16 kilohertz for a couple decibel, but this would sound pretty nice in recording. That's the tape. See, there was some issue in the tape. It's continue pretty good. Like it starts from like 13 kilohertz and slowly rise for like maybe 2 decibel by 16. It will give some clarity and it will help with 10 kilohertz, minus 10 decibel. 0 decibel. I believe this intermodulation. So let me record because it just cannot be so. Let me see. It happens 4, 5, 6, 7. Let's do like 20 seconds because I don't believe that it records 20 kilohertz here. We've seen like on the oscilloscope that it's not true. All right. Yeah, that's closer to reality. Let's do minus 20. And this like spikes, it's a result of 2 capacitors we added to correct the curve for the playback amplifier, right? And with this correction, it plays like all tapes, like from other decks, fine, like Dolby tapes, factory tapes, fine. And if I don't do it, we will have like a more flat curve here, but it would not play well other tapes, only its own. Like so, now that's exactly what I have heard from the guys in Russia who was fixing the same decks. It's channel Radio Lab, and he gets the same results. So he finally removed capacitors, make it flat recording, but who wants non-compatible deck, right? All right, so let's rewind. Let's see. Yeah, that's the results. That's what we recorded. You see? So that spike was from intermodulation. It records pretty well, like 218 kilohertz on type 1 tape. All right. So validated. Not that good as Nakamichi on the high levels, but still like sound from this deck is very, very good. You would not regret if you get one. All right, let me test other tapes. How it will calibrate. Now, chrome tape. I will not use scalp now because we need to maintain levels. So I will use just rec and it will calibrate tape, but would not adjust levels for us. You see it's even measured mole level and show us right here. All right, so let's see. Let's record. And it's what it shows during recording. This tape, like, probably is bad already. I need to get one more. See, touch this balance between left-right channel from bias perspective, just on one tape. Maybe like get me another one chrome tape. Let's do this one. Yeah, that's much better. And again, you see this bump? I believe this like effect between two heads. And we will validate now. All right. Let's record like 30 seconds and rewind and see. Why 30 seconds? Because we need time like to program to integrate white noise like to average values. So. All right, and that's what we recorded, so it's pretty flat. Come on, it just was better. Really. Should we try one more time? That's say tapes, they are not all good. I probably will switch to UX tape for testing and tuning because I'm experiencing problems with these tapes. That's what it shows during recording. All right. And those spikes are like our power supply. I don't see it during playback. So let's test again. 60 gears and 30 gears. Yeah, they still, we can see, but you see it records pretty nice. On the good tape, it will record like up to 20 kilohertz. Good. Now let's see metal tape. So I like this tape. DKMA. All right, let's record because it shows the same rise as see during recording. Let's record and see what would be the result. With this deck, we have to do it like, to validate, because like I believe that was the reason of the guy in Russia. He said that he kept those removed those capacitors because like he's seen results like. But probably that's the reason, like it's intermodulation between two heads, records and playback. Alright, let's see what we get. And that's what we get. Clean 20 kilohertz. Ooh. Tune it, finally. Happy. Now I will zip tie all wires and close it up. Whew. Long ride, right? An indicator again, like or like I'm used to this bright lights and computer in front of me, but it's not that bright as I want it to be, really. And I've seen like on videos on YouTube, right? These elements down here, these lines, this line, they're not that bright as on the other decks. So far the brightest I've seen it was Iowa S7000. That was super bright, really, maybe even unknown bright. And good on Sony KS7 555, so the level's good. All right. So I'm happy. Are you? So see you in the next parts. Like I believe this would be it for tonight. I'm ready finally to assemble this deck. Finally, I'm happy with the results. tuning of this deck is sophisticated, to tell the less. I'm not sure why they did that way, but it should be easier. They already been like producing computers this years, right? And there was like such teeny like switches when you like shortcut when you can put into different pins, right? So like this older computers, there was manual shortcuts when you can configure. So the same could be done here. You don't need to solder the solder wires like so on. Specifically, they have two computers. Just like to calibrate it and operate it and work with display another computer. Like it's having three computers and don't think about like simple things. It is what it is. All right. So the only thing I'm not happy with this deck is recording Azimuth, and I check it up. Tape pass, it's fine. Like I cannot do more. I tried to adjust to see how it will affect. Nothing helps. So tape pass is good. You've seen electronically, we can adjust Azimuth, but then like it will be very disbalanced between left and right channel. So my understanding at this point in time that heads or materials or coils, or like whenever this happens, heads work differently, record heads specifically, right? And like that affects how much bias we need to do to give it to record the same proper amount on the tape. And like this, the difference is big, and it produces phase shift. Explanation for this phase shift, like I've seen in another guy, Alexander Mirgorodsky video, and he did show on Pioneer adjusting bias how he can change the recording azimuth, right? So technically the same as I did here. And he explained it theory. So if you would want, so YouTube now translates, so you may just like watch subtitles. So I hope in the future they will translate audio as well, as they do currently with Japanese channels. I'm watching them like with big pleasure, because now I can just listen. I don't need to read subtitles. All right, see you in my next videos. Hope you enjoy my channel, and bye-bye. And bonus video, I'm recording music, so source. And tape. Really, very good results. I'm also want to check auto recording level, because I believe it's too conservative on my mind. It gets like 0 plus 2 decibel. It's like rarely gets to Dolby when it's a set. And I believe with this Sony tape, it can go like plus 6-8 decibel here easily. I need to check levels like one more time for another ADC. Like there are so many of them on this board. Okay, but recording results, guys, it's really good. I will make a video and like record and play on this deck, and you will be really excited because results astonishing. See you. And final step, I checked all AD converters and everything was fine, right? But when I started to look here, you see it shows like 0 decibel, which is below 3 decibel below the Dolby level, right? View meter, and it shows energy, and it shows view here. If it switch to pikes, Dolby symbol is here, and it goes like definitely +1, +2 decibel on like a normal level, like 250 nanoweber. So it does perfect job with levels. So it just like the view mode. So here you would not see it goes +4, right? Plus because its view is energy level. It's calculated different, the same as is needle indicators. If you will see, there is like nice IVA decks, 6900, I believe 6800, something like that. They have double needles. One needle shows VU level, like energy, and other needle shows spikes. Here I observe the same view and peak indicator. It works differently. And here is the spectrum. So you may see that only low frequencies goes that high, and pikes on the high frequencies are definitely lower. The only thing I need to read is read about the small indicators, like what level they show. My understanding they show like view level, because they are pretty close to what it displays. Right here the spectrum, you see they never go much higher from energy perspective than mole and sol level. Okay, pretty sophisticated deck, records beautifully. Like I'm listening to recording, so source tape, like it's almost not possible to distinguish. Type 1 with Dolby B, perfect. Alright, see. Alright. Final part. Assembled. No need to open anymore. Plays and records very well. Works quietly and quickly. So, guys, you need to know, right? This deck, as you've seen, the real motor is located not in the middle but shifted due to size constraints, and as a result they also put like 1:3 ratio, like and not rollers, how they pulleys, right? And these pulleys like reduce the speed of the fast forward rewind. So even in the original article, it says like it's rewind like more than a minute for 90 minutes tape. Alright, you see. It works, it's fine, it's quick enough, but it's not as quick as many other decks. And that's only this like pulleys, this ratio, like it reduces rotation speed like 3 times. Alright. Plays, really nice deck. That would be it. See you. Subscribe to my channel. Appreciate donations on the Patreon. Just go there and buy thank you cards if you feel that you are generous enough to appreciate my work. Thank you. See you and bye-bye.